right, so chapter 9 is pretty much the study of right triangles, like the whole chapter. Okay, and we start by classifying the triangles, and then we get narrow into just right triangles, and we learn about trig, which is like the study of that triangle, like SOHCAHTOA, or sine, cosine, tangent. That's the end. For right now, we're just establishing if it's a right triangle, what's the relationship between its sides, and then if it's not a right triangle, how do we classify it? How do we know if it's acute or obtuse just based on its side lengths? So the first thing, and this is probably one of the most popular things in geometry, is the Pythagorean Theorem. And it says that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. In other words, and this should be actually squared, a squared plus b squared equals c squared.
Yep, just how I remember.
The important part of this is that the c is the hypotenuse. So how do we know it's a hypotenuse? From a picture, it would be opposite the right angle. From lengths, it's the largest side. So it would be the biggest number. So you'll use this two ways. One is, here's two side lengths, find the third. And the other is, here are three side lengths, is this a right triangle? So the initial Pythagorean theorem and then the converse to it. They're common triples, okay? And common triples are time savers. They basically eliminate work for you. If you're given two side lengths and they are the legs, meaning the smaller side, so not the hypotenuse, and it's 3 and 4, then you know that the hypotenuse is 5 because 3 squared plus 4 squared would equal 5 squared. Then the other triples that are the most common, so these are the most common ones. This is not the limit to them. There are more. But 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, 25.
See a common theme between these?
And that is?
There is none.
Nope. Nope. So it goes pairs.
If you double the first one, you get this one. That is 1. But
Well,
then it stops there.
No. So it's only on the last two numbers. So it goes 4, 5. That's plus 1, right? And the next one's 8, 10, it's plus 2, then it's 12, 13, which is again
Oh my
plus
gosh.
1. And
Okay.
15, 17
All right.
is plus 2, and then 24, 25.
But what happens if we put the 7, 24, 25 before the 8, 15, 17? That messes up your whole pattern, right? Don't do that. Just memorize these. If you don't memorize these, then you would have to use the a squared plus b squared equals c squared and do the work. For most of them, it's not so bad. Like if I had 5 squared and 12 squared and I just want to do the work, those aren't awful numbers, except if you forget that the square root of 169 is 13, which some people do. But something like 17 squared, when you get to 8 squared plus 15 squared, is 289. That's not a common perfect square. So that's where these are much more beneficial, okay? So again, if you see 2 of these 3, you can find the third. Just make sure that it's the right one. If I give you a right triangle and I say that this is 3 and this is 4, the missing side is not 5. Why?
Because the biggest side would have
Good. The biggest side would have to be 5. Does that make sense?
Yeah.
So be careful with your triples. Just because I give you 2 side lengths are 3 and 4 doesn't mean it's always 5. All right, so this says find the values for x and y. Again, they all have to be right triangles for this to work. So they are. It's a little hard to see the little like square in the corner, but that is what marks a right angle. So I would say that 5 squared plus 10 squared equals y squared. 25 plus 100 equals y squared. And 125 equals y squared. And then I would square root both sides. And normally I would say plus and minus on the front of that, but because we're talking about a side length and a side length can't be negative, I don't worry about the plus and minus. I just square root. Is 125 a perfect square? No. Can I break it down? 5 and 25, 5 and 5. So a pair of 5s comes out as 1 5 on the outside, and then the single 5 that doesn't have a match would stay underneath. So they have to be simplified. Jonathan, did that answer your question? Or you have one? You have a question? Or and answered the question?
That's rude.
Answered your question. Okay, thank you. All right, B. Okay, there are two y's there. They are the same variable. So 5 squared. Huh?
Sophia, bro.
What'd you say?
Is it 4?
Oh, I'm not there yet. No, it's not 4. 5 squared plus y plus 1 squared would equal y squared. And then you have to square the 5, obviously. You have to expand and FOIL this. We do not distribute the exponent here. So this is y minus 1 times y minus 1. Yep, algebra skills. Y squared minus y plus 1. Y squared minus 2y plus 1. That replaces this whole thing. It's expanded, that's all.
Oh, slow down.
Wait a second.
Any way you can shortcut this?
There's a shortcut. It's the first one squared, the second one squared, double the product of the two.
Never
First
mind.
squared. Squared.
And how do you simplify this?
What, you tell me. What would you do?
I mean, combine like terms.
Combine like terms. So I'd get y squared minus 2y plus 26 equals y squared. Then what?
Oh my gosh.
Wait, can you square? Wait.
This was the
Wait,
hard
square
part of
root.
algebra.
Mm-mm.
So then you combine like terms.
I did. Now what?
Can you subtract?
Then you
Subtract the y
square
squared.
root.
What happens when you subtract y squared from either side?
You get 0.
Cancels out, and I get negative 2y plus 26 equals 0.
So like
And then
negative 2y equals negative 26.
I can move the 26, or you could have moved the 2y. Doesn't matter, right?
I like when my variables on the left.
Okay. And y is 13.
Can I see the FOIL part here?
Yeah,
first outside.
that's this one. So we trade the proofs for the algebra skills.
I'd rather.
I think the
All right, so C, and this is a square root, should go all the way over. X squared plus 3 squared would equal 3 times the square root of 2 squared. So x squared obviously says x squared. 3 squared becomes 9. And then there are two ways to do 3 square root 2 squared. You could either duplicate it and then multiply it out. So I could do 3 root 2 times 3 root 2. And you multiply the ones on the outside. That's 9. And you multiply the 2 on the inside. Square root 2 times square root 2 would be what?
Or 4.
Square root 4 or
2.
2. And that would be 18. That's one way to do it.
Not hers.
The other is they both get the squared. So 3 squared times the square root of 2 squared. Or 9 times 2, which is still 18. I would probably do the left side, but you get to choose. Mars.
Why is it times 2 again?
Because root 2 times root 2 is just 2.
so you
Oh.
Any root times itself, you eliminate the square root.
That makes sense.
Wait, so it went from square root of 4 to. Oh, and then it was 2.
Yep. You just don't have to do that step. Any root times itself is just what's underneath. Yeah.
Oh yeah, I remember that. It would just be 3 squared times 2. Then turning it back to the original.
Correct. All right, then subtract the 9, and x squared equals 9. So x would be 3. And again, in algebra skills, it's actually plus and minus 3. But because we're dealing with a shape here in which sides can't be negative, we ignore the negative part. We just square root. Still good.
Ready for the next page.
So excited. Questions?
You said like any square root times itself, you just get rid of the.
Just get rid of the root. So square root 5 times square root 5, just 5. Yep. You could do the long way around. It would be square root 25, but then you got to break it back down again. Yeah,
Square root of 25 is opposite 5.
that is correct. You don't have to do that. All right, example 2 says find the length of a diagonal of a rectangle with length 8 and width 4. So I would say most people are visual learners. If it helps you to draw it out, draw it out. If you don't need it, then don't worry about it. But the length, being the longer side, would be 8. The width would be 4. And the diagonal, and it doesn't matter which way you cut that diagonal, the sides of this are going to be 4 and 8. What's true about the angles in a rectangle? They are congruent. What else? They're all 90 degrees, right? So here's a 90 degrees. And we just made our our rectangle into 2 right triangles. The diagonal, yes I did, and then I corrected myself, thank you. And then the diagonal gets your x. So then it's 4 squared plus 8 squared equals x squared. 16 plus 64 equals x squared. And 80 equals x squared. So x equals the square root of 80. Is that a perfect square?
No.
So we break it down. 2 and 40, 2 and 20, 2 and 10, 2 and 5. And there are 2 pairs of 2s and 1 pair or 1 single term by itself. So it'd be 4 square root 5. Come on. Nope. I mean, you can, but you won't get the full points. Yeah. Questions? Still not so bad. A little bit of application, a little bit of blending the geometry with the algebra.
Is 16 times 5 80?
That is correct.
Oh, I remember how to find it.
All right, example 3 says find the diagonals of a rhombus, the diagonals of a rhombus have length 16 and 30. Find the perimeter of the rhombus. So rhombus, what's true about a rhombus?
4 sides.
4 sides, 4 congruent sides. What's true about their diagonals? They are bisected. So if one is 16, like if this whole one is 16, then this is 8 and 8. And if the other one is 30, then this is 15 and 15. What else is true about the diagonals that would be crucial to this lesson?
The diagonals are perpendicular.
They are perpendicular, which means
90 degrees.
90 degrees.
4 right angles. So there are 4 right triangles in here. Each of them have legs of 8 and 15. So the hypotenuse on an 8, 15 blank triangle would be what? It's a triple. 8, 15, 17. Good.
Based on rhombus, you just have to imagine actually a square that is just laying down.
A slanted square, kind of, yeah.
But then
But a rhombus is 4 congruent right triangles. The
How'd you get 17?
8, 15, 17 is one of my triples. Let's say you don't know it. 8 squared plus 15 squared equals 17 squared. Equals x squared. It'd be 64, 225, and that's 289. That's not a common square root, people know. So that's why that triple comes in really handy.
has to be 17.
Yeah, and there's no way to break it down, right? Because it's like prime. So it's not prime, but 17 is prime. So you can't go 2 into that. I can't go 3 into that. The only way to break it down is 17 and 17. But did it ask for a side length?
No.
What did it ask for?
Perimeter.
So
It's 68.
how do I do that?
17 plus 17 plus 4.
17 plus 17 plus 17 plus 17, or 17 times 4.
Mars,
Good job.
great job.
Yay.
Questions on that one?
You just leave it for like 2 minutes. Right?
Sure. All right. Now we got a triangle split into 2 smaller triangles, right? What kind of triangle is the big triangle?
Oh, it's a nice sauce.
It's isosceles because these are the same, right?
Yes.
What happens when an altitude hits an isosceles at the base?
Creates 2 right triangles.
You're both right. The altitude creates the right triangle, and it bisects it or cuts it into 2 parts, 2 equal parts. So now I've got 2 right triangles, and they're both the same. You could pick either one, where the legs are 3 and 6, and the x, which is the hypotenuse, is what we're looking for. So 9 plus 36 equals x squared. X squared is 45, which is 5 and 9, or 3 and 3. 3 root 5. Good. See? Just some practice. Square root's obviously an important skill that carries over. Yes?
If you don't get a pair like we just did now,
Yeah.
is it gonna be the first one on the inside?
Square root of 45.
Say that again. If you don't
So
get...
if you have a pair of anything, it always goes on the outside.
Correct.
Whichever one gets square rooted goes on the outside.
Correct. Which is why the pair would work. Yep. All right. Now the converse to the Pythagorean theorem. So what is converse? Reverse the order, right? So if the original Pythagorean theorem said if a squared plus b squared equals... If a squared plus b squared equals c squared... I'm sorry. If it's a right triangle, then a squared plus b squared equals c squared. And now we're reversing this. I don't know why when I made this a PDF, it lost all my squareds. If, now we're saying, if a squared plus b squared equals c squared, then it's a right triangle. So it could give you the lengths of 3 sides, and it will say classify the triangle, and you're looking to see if it's a right triangle. If the 2 smaller sides, and that's how you would know because you won't have a picture, you won't have a right angle, you would have to square the 2 smaller sides. And if when you add that, it's the same as the square of the 3rd side, then it's a right triangle. Yeah, we're not even, it's so easy, but we're not even gonna go to the end today. Normally you could go to the end, but because we're on a shortened schedule, we're not gonna go all the way. The Pythagorean inequalities theorem, and this is 9-3, so the numbers change, but again, numbers are not important. What they say is important. Says if the square of the longest side of the triangle is less than, so instead of equal to, we're saying less than, the sum of the squares on the other sides, then it's an acute triangle. And again, this should be c squared is less than a squared plus b squared. So if it's less than, it's acute. If it's equal, it's right. If it's less than, it's acute. If it's greater than, what do you think is going to happen? It's obtuse. That's it. That's the whole lesson. So if it's less than, it's acute. And if it's greater than, it's obtuse. So if you put c first, when you write this out, instead of doing a squared and then b squared and then c squared, if you put c first, I think it's the easiest way to remember. Less than would be small, so it's acute. Greater than, bigger, it's obtuse. If you switch the order, then it gets confusing. So like if I said c squared equals a squared plus b squared, it's a what?
Right triangle.
It's right. If c squared is less than a squared plus b squared, we think less than, so we think smaller, and smaller would be acute. And then if it's greater than, which is the next slide, it's obtuse. So if you can just remember and you put the c first, then it makes the most sense. When you start to switch it, that's when it gets confusing. All right, so work these, but we won't even finish them, okay? It says the sides of the triangles have the lengths given. Is the triangle acute, right, or obtuse? And some, like a standard test might even ask, is it possible to form the triangle? And if it is, classify it as acute, right, or obtuse. So if it says, is it possible to even form it, then the sum of the two smaller must be greater than the third. And that goes back a couple chapters. third side. So like if you end up pulling a practice sheet or something like that, and it could say it's not even possible for that triangle to be formed. That's what it means. So if I add 20 and 21, is it bigger than 29? Yeah, so I know the triangle can be formed. Now I've got to classify it. So the bigger one goes first because that would be my C. 29 squared has what relationship to 20 squared plus 21 squared? So 29 times 29. Yes, agreed. 841. And then 20 squared is 400. And 21 squared is 441. So what's the relationship between 841 and 841? They're equal, which makes this a right triangle. So the first check is, can it be? Add the two smaller sides together. If it's bigger, then it's yes. Then go to the C squared has what relationship to A squared plus B squared? All right, go to B. So 20 plus 21 is what I would check first, making sure it's bigger than 30. Is it?
Yeah.
Yes. So then 30 squared has what relationship to 20 squared plus 21 squared? 30 squared would be? Good. 20 squared?
400.
Good. 21 we just did, 441. So 900 has what relationship to 841?
It is
Greater than, which makes this triangle? Good, obtuse. So you're going to see ones with square roots and stuff like D. We'll get to that one tomorrow if you want it. But you could work all the way through, but the homework's not going to be due till Monday. Okay, so we're going to make one assignment, but it won't be due until Monday because some classes were shorter than others today. Questions on anything, though, because you basically learned all the concepts. You could get all the way through. And all of them require work, folks.